Yes, guys. Why sea is blue? What are we discussing? Why sea is blue? Give it a try. Say something. Say anything. Why sea or ocean is blue?
Sir, does it absorb the red wavelengths?
Yeah. Now, if I go by scattering funda, just listen out and tell me where it is wrong. If I go by scattering funda, then your blue light is really low wavelength and red light is high wavelength, right? Hmm? Molecules are closer in water than in air, right? Right?
Yes.
So what happens in air in kilometers, it will happen in say within a meter, right? Right? And is going to scatter the blue light. And the scattering means the particles are giving blue light, so it will seem blue. It comes blue to you, right? Right? So what sky is doing in kilometers, it is able to do. It is much more dense, so it is able to do faster. Hence, your sea is blue. What is wrong in that explanation? Anything wrong? Seems all right, right? What's wrong?
So you had told that what is it, dispersion happens more in
Dispersion. Why are you saying dispersion again and again?
scattering of light happens more in less dense medium, like in you had told in atmosphere, it happens more in the top.
Hmm. Yeah. Okay. I told that. Why? By all logics, I showed the Tyndall and all, right? By all logics, if I have more particles, it is getting more opportunity to scatter, right? Right, people? Yes, people. Anybody else? If molecule has to scatter, it must be Rayleigh scattering which is happening, right? Hmm? If Rayleigh scattering was happening, my blue scattering would be more dense near to the surface of Earth than the top of the Earth, right? And that is what who was saying? Utkarsh was saying. That your
Yes, sir.
scattering is actually happening in the thin places and not at the dense places. So here scattering must not be happening at the dense place, right? Is what you were saying, right? And it is what I said earlier, right? Get the point? Get the point?
Yes, sir.
Hmm? Now, like how why do why do I believe myself in this? It defies the logic. So I have an observation. I have an observation which is a big difference between what is happening in sky and what is happening in the sea. If you go deep over here, if you go deep down, then what happens? If you go to this depth, suppose you go to this depth, what is it? It's blue. Are you understanding? When you're looking at, say, trying to look at sun from here, it will seem blue. Are you getting the point?
Yes, sir.
That's a surprising thing, no? Between what I said in the color of the sun when you look from land, when you look at the sun from land, what color it looks like? Reddish, right? Or yellowish or whatever, right? Deprived of blue, right? So the surprising thing is when you try to look at the object outside from here, it is blue. The sea is blue over here and not red. That's a big difference, no? When you go deep down, it is what? It's black, we know, right? Get the point?
Yes, sir.
So the point is here, due to the molecular structure of water, it is able to absorb red light. Okay, so there is nothing like a big deal over here. If I say my shirt is green, why is my shirt green?
So because it is absorbing all the wavelengths of other lights except green.
Yeah, because it is absorbing all wavelengths except green. Get the point? So it is reflecting green, right? Right? If my shirt was transparent and still it absorbs all wavelength, if my shirt was say transparent, okay, and it absorbs all wavelength, it absorbs, okay, I'll just draw the line straight, okay, it absorbs all wavelength except green, then what happens? Due to its molecular structure, no longer due to its wavelength is high, wavelength is low, la 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 la, lulu lulu, then what is going to happen? Suppose it is transparent, what is going to happen?
It'll look green because
Yeah, green will come from the other side, right? Hmm? And if it is not transparent, green gets reflected, right? Right? So why is a certain shirt color or pigment color a certain color? Because it absorbs the others and reflects the one which is not absorbed, right? Same with water, except for the fact that light can travel through it, it is not getting reflected. Okay, a bit is getting reflected, but mostly it is traveling through it. So the white light came, some white light got reflected, or whatever light came, it got reflected. But the one which is going down, there is no scattering like this happening. Okay, what is happening is your blue is able to pass. Why? Because the molecules are not interested in blue, they are able to pass, and hence the C, you go down over here, it is actually actually if you look at something which is illuminated outside, it is bluish for you. So the whole thing is looking like blue from here, and the red is absorbed, gone. Like you look at the shirt which is green, do you see any red in it? Because it has absorbed red, do you see red in it? Obviously not, right? That energy has gone into the vibrations of the molecules, right? Right? Or the electrons, right?
yes, sir.
Is that clear? So since we know that red is not passing through it, it is not having the same concept as why sky is blue. In the sky, the blue got scattered and the red passed through, right? Red, right? Red, green, whatever, they all passed through, right? Is that clear? Here the red got
Explain why red does
absorbed.
not pass through.
What?
So can you explain again why red doesn't pass through?
Same as any pigment, any colored thing. Why is it colored? Like tell me of a colored thing, you know.
Sir, ink, it is blue ink.
Yeah, you don't have to actually go for like liquid and transparent and all. Yeah, blue ink. Why is it blue?
So because it absorbs all the colors but it reflects blue.
Yeah. So what were you asking over here? What are you asking over here?
So why red does not pass through?
It absorbs like your ink, which is blue. Water is actually blue. Water is actually a very, very, very light blue, which in a glass you won't able to make out. But if it is like massive amount of water like in lakes and sea, you are able to make out. Because like ink you said, no, it is blue.
Okay, sir.
It
So
absorbs,
red.
it absorbs red and reflects the other. Okay, maybe reflecting this side, that side, or passing through. Get the point? Are you understanding?
Yes, sir.
So if it is doing that, it is not scattering. Okay, is that clear? It is not the concept of that the lower wavelength got scattered and the higher wavelength passed through. We are seeing that the higher wavelength never passed through. Okay, so it is same as why pigments are of a certain color. Get the point? So that's a big difference. Okay, so sometimes they say it is because of scattering. That is a wrong answer. And obviously a bit of the other answer is your sky is blue. Your sky is blue. Right? Your sky is blue. That means the light coming from the sky is blue, right? So it is going to reflect the light, no, which it is coming from the surface. So it reflects. Suppose you keep a certain object over the surface of water. The object color was say orange or whatever. It will reflect that color, no, and you'll look at the object in the as a mirror. You look it in the water, right? Right? And some orangish object you can make out, right? Similarly, the sky is blue, so as a reflection you can make it out, but that is not the major part. Okay, that's not the major part why it is blue. That's a very small part because the reflection itself is much lesser than what is going in inside water. Is that clear, guys? Is that clear?
Yes, sir.
Okay.
Yes.
So why
So can you just explain why this blue in color, black in color when you go deep inside?
black is not a color, by the way. Sun is blue in color is a very dramatic way of telling you so that you get an effect. Okay. Let me again put it. Suppose you believe what I'm saying, right? That this is what is happening. Then you tell me this is sun. It gave white light. Okay. So white light is coming. Then white light is made up of what?
7 colors.
Yeah, red. Okay, I'll draw green also. I'll draw blue also. And of the whip, excuse me, of the whip gear, the water has a property, like any colored thing will have a property. The water has a property. In class 12, either me or Raki ma'am or Divyanshi or somebody will be telling you why those are having a property. They'll tell you about the electron jumps, what is happening in a orbital. But anyways, water is having a property of absorbing these colors. Is that clear? The wavelengths which are near to this, it has a property of absorbing that. Absorbing means what? Those energies are just gone into the molecules. Is that clear? And the molecules have become more, say, vibrant or energetic. Is that clear? This is gone.
Yes, sir.
So if that is happening, if you believe me that that is happening, because it happens with every object, no, every object absorbs something or the other and doesn't absorb the other thing due to its own molecular structure, okay, atomic structure. So water absorbs this, then what do you think is going through? What do you think it is, say, reflecting or letting pass? So it is either reflecting or letting pass which color?
Sir, blue.
The blue, the green, right?
Yes, sir.
Right? So it is like greenish yellow. This, if I say this much is gone and this is remaining, it is more profound of a blue, right? Get the
Yes.
point? Okay, blue it is not taking at all, right? So blue is what is passing through, blue is what is getting reflected. So if somebody is over here and wanting to look at the sun, then this is the light, no, one light which is really coming down. This is the light, right? It's actually coming from the sun, right? So it may seem like the sun is bluish, right?
Yes.
दिस इज लाइक हाईली एग्जैजरेटेड ड्रामेटिक थिंग, क्योंकि क्या हो रहा होगा कि आपका आसपास में भी सब जगह से ब्लू लाइट रिफ्लेक्ट हो रहा है फ्रॉम द वाटर, राइट? सो द होल ओशन लुक्स लाइक ब्लू फ्रॉम इनसाइड. Get the point?
Yes, sir.
Okay, but saying that the sun is blue is really cool, no? ठीक है. So we'll have to go to a very very nice height from where we can have like enough red absorbed away and enough view of the sun, so that we look at it as slightly bluish. That would be cool. I'll try to get a pic in Google if we have such a pic. Okay.
Sir, so if we pass a yellowish light through a glass of water, it
Yes,
would-
and then comes to the black. Let me just finish her this thing. Okay. Ultimately, light is getting. It's like red was getting absorbed and blue is not. But ultimately, जो reflection हो रहा है इधर उधर से, ठीक है? The light is going to get all consumed or all absorbed. Okay, it is not like nothing of blue was getting absorbed or something. Okay, light is energy. Okay, it was more of a red getting absorbed, less of a blue. Okay, much less of a blue. But ultimately blue is also gone and it is all dark in the bottom. Get the point?
Yes, sir.
So they also say that deep water fish, they are red in color. Why are they red in color? I mean, if you take them out and watch them, see them, they are red. Why? Because red in deep ocean is as good as black. Why? Red things, if I shine blue light on a red shirt, what is going to happen? That's my red shirt. Red shirt. Red shirt. Okay. And I am in a room which has just blue light. Blue light. What is happening? It is getting absorbed, no? Doesn't have any red light to reflect, right? Red shirt is red, only red light, right? Or in white light which has red in it, right? White light आएगा तो red को reflect करेगा, right? But I don't give any red light to it, then what is the color of this? This is black, right? This, you go to some say club or disco place or this or that, and in a colored light you can see of all these effects. Get the point? This also as an experiment you do in your house. You take what do you do? 1 second. You take a transparent film, a cellophane paper or something, and make light go through it. Light is going through it, white light. So these allow red light to pass, right? So red light will come, you have red light, right? Get the point? Then take a blue object or a green object, whatever, and try to see the color of that. It will no longer be blue, right? You'll have to do in a dark room. Get the point?
Yes, sir.
The blue object seen here, this is white, sorry. Here the blue object will be blue, right? Because it will reflect blue, right? But here after the film it will be dark, right? Is that clear? So
Yes.
what was I saying? I was saying that those red, if I have a red fish, and I take that red fish deep in the ocean, what is it now? It doesn't reflect any light. Why? Because there is no red light, right?
Yes, sir.
After a certain depth it is generally blue light, there is no red light, so it is dark. Get the point? Is that clear?
Yes.
So it's not like the fish are knowing. If you go and study or you would have studied the evolution, law of evolution, right? What is that? Whatever survived, right? Suppose we had all colors of fishes, then the blue ones are easily detected by the prey. They become the prey, the predators. They are detected by the predators, right? The red ones are not. So they got killed. The red ones survived. So the ones survived, they had their own vanshaj, their own children who were red, right? Get the point? Therefore you have green caterpillars on leaf not being seen by, say, the birds easily. You have brown earthworms. Camouflage is happening everywhere. Any doubt, guys? Why sea blue? Is it clear? Not because of scattering. I'll send you a pic of a place where they have, after writing everything right, they have written it is because of scattering. Okay, anything else, people?